potential earthquake or landslide or seamount slide risk possibilities for tsunami, one affecting the west coast of the United States and one potentially affecting the east coast of the United States. Not saying that this is going to happen or would ever happen, but since we know enough about tsunami that have occurred in the past, we can look forward to uh, places where tsunami could be triggered in the future, and then try to develop early warning systems with either buoys in the ocean or by detecting them by satellite or just through earthquake activity. One of them is Hawaii. So if you're remote right now, in the plan for the week, in the Waves, Tides, and Coast unit for today, there's a thing that says Hawaii as a tsunami, or well, this is actually yesterday's link. Hawaii is a tsunami generator. If you click on that link, it takes you to a YouTube video. I'm going to play it here in class that describes, potential risks related to Hawaii. This is only like 4 minutes. Let's get this going.
One type of location was particularly vulnerable to landslides: large volcanic islands. There are dozens of such islands scattered throughout the world's oceans, and the reason they are prone to landslides is because of the way they are built. These islands began life millions of years ago, when lava erupted onto the ocean floor. As this cooled and hardened, layer built upon layer until it formed a land platform of volcanic rubble above sea level. Scientists realized that every few thousand years, one of these piles of volcanic rubble had fallen into the sea.
Volcanic islands grow by one lava flow after another over tremendous amounts of time. As they do this, they become oversteepened. At the same time, you have the ocean eroding away at the base, and eventually all these things together end up weakening the edifice to the point where it collapses.
This is Hawaii, the largest chain of volcanic islands on Earth. These scarred valleys are where vast sections of Hawaiian coastline fell into the sea hundreds of thousands of years ago. The mega tsunami they created would have been thousands of times more powerful than Lituya Bay. Underwater lies the debris of ancient Hawaiian collapses. Whole chunks of the islands have fallen onto the sea floor. The biggest section is the Tuscaloosa Seamount, a giant block which fell off the island of Oahu 2 million years ago. This single rock is almost 10 times the volume of Mount Everest. When it hit the water, it would have created an unimaginable mega tsunami. It would have taken 5 hours to travel across the Pacific and strike the west coast of America. But this event was not unique.
Well, what we notice when we start looking at the volcanic islands is that every archipelago has collapses. The evidence is insurmountable. Everywhere you go, you find evidence for debris avalanches, slumps.
The Cape Verde Islands in the Atlantic also had a massive landslide. This was 80,000 years ago. The mega tsunami this created would have taken just 1 hour to strike the west coast of Africa. These volcanic island collapses seem to be rare, only happening every several thousand years. The most recent one is thought to have occurred in the Indian Ocean. A part of the island of Réunion collapsed just 4,000 years ago. 7 hours later, the wave it generated would have struck Australia. Although this is believed to be the last volcanic island to collapse, it seems inevitable that somewhere it will happen again.
You can't build islands over thousands of years, flow after flow, without having collapse. It just is part of their nature, it's part of their history, and it's part of their future.
And then, let's see. So the other one that people talk about is there's an island in the Canary Islands in the Atlantic Ocean off the west coast of Africa. The volcano is called the Cumbre Vieja volcano, and the island is La Palma. La Palma is famous for a couple other things too, and I'll show you like where that is. But there's a Wikipedia article, and people talk about the possibility of Cumbre Vieja having a landslide on its west side and then coming across the Atlantic Ocean toward the Atlantic seacoast. All right, so here's the thing that the guy was talking about the way that volcanic mountains or volcanic islands are built and how that compares to mountains like we have here in Pennsylvania. So in Pennsylvania, like around here, we mostly have sedimentary rock, and that sedimentary rock is formed in layers. And then as continental drift takes place, tectonic action, if you have to move the land this way and move this land this way, as the land has to squeeze together, what you end up doing is forming this region in central Pennsylvania called the Ridge and Valley region. So a lot of our mountains are these like humped things that end up to be like long and straight lines, and the layers of rock end up getting folded like this. And that folding of the rock is, you know, relatively stable. It's a nice, nice, even, regular pattern. So whenever you look at, like, let me get to show desktop, I had to get a new window. Let me get to it always feels slow when I want it to go fast. Yeah, so here in central Pennsylvania, these series of mountains that form these long mountain chains, like Bald Eagle Mountain, which starts like by Muncie, you can see it as you look across the river, and it runs all the way down like to Tyrone and Altoona. These ridges that are folded are nice long parallel lines. If you cut it sideways, then you see this like regular, nice folded pattern, and it's relatively stable. As opposed to that, if this is the ocean floor and then this is the ocean surface, when volcanoes erupt, they end up forming rock, and the rock might be like a rubble here, and then especially for hot spots like Hawaii, then the next pile of rock is here, and the next pile of rock is here, and then it just kind of keeps ending up, as the volcano erupts, building a bigger and bigger island. But each eruption causes these rocks to be, you know, kind of like a rubble of rock kind of built up. And then the deal is, as that mountain ends up extending above the ocean surface, in Hawaii and other islands around the Pacific, there's actually not that much rock that's above the ocean surface. Most of the rock is down below the ocean surface. But as you pile more and more rock on top, it puts in a lot of pressure, a lot of weight down here, and it tends to make landslides happen. So this seamount here, this whole piece, as a result of weight on top, might just slide down in the ocean and create an individual tsunami. And the place in that video that they illustrated that was very easy to see those scars is a place on the west coast of Hawaii, of the island of Kauai, called the Nepali coast. And it's one of the most spectacular sights you can ever see with your own eyes. But the Nepali coast has these very deep scars that exist in the side of the mountain, and they're nearly vertical lines. It isn't as if the volcano was ever built in this way, but instead, this is indication of the volcano having sloughed off down into the ocean. So what you started with was maybe like the ocean surface is up here, and you have your volcano, which is kind of like that. But because of rifts in the volcano, you end up with these vertical lines, and it's these vertical like rifts in the rock where there's different layers of volcanic activity, and this whole thing can slide down into the ocean. And if this whole thing slides down in the ocean all at once, you get a big tsunami wave that comes across. So the few risks that exist for the continental United States, like you don't have to worry about it here in Williamsport. We don't have to worry about a tsunami, which is good. But places in the coasts do. So the few places that you could be concerned about are there's a ridge, an underwater mountain range that exists off the west coast of the United States, but not far off the west coast. And the Seamount Slide on the west coast would give you a very short period of time to provide a warning to people who live in coastal areas in Oregon, Washington, and California. Those are the only 3 states on the west coast. Show you where that is. So if we run around here to the west coast, you can see that there are these transform faults and some seamounts that exist off the west coast. This is Washington State, Oregon, and California. And a seamount slide from these seamounts here or any disruption on these faults could cause inundation on the west coast. So that's a possible risk. And the time for a tsunami to get from here to here is on the order of minutes to an hour. A large tsunami taking place as a result of a landslide in and around Hawaii would take much longer, like on the order of 6 or 7 hours. So we would be aware of that. But here on the east coast of the United States, there are no real tsunami risks all the way from the east coast out to the mid-Atlantic ridge. The risk is very modest. But here, just off the west coast of Africa, there are sections of islands, like up here, that could have seamount slides that would cause, damage to the west coast of Africa. But there's not very many populated areas. In fact, if you zoom in here, you see the Sahara Desert goes right up to the ocean itself. And these are, I don't know if is this populated? Yeah, there's a small, well, it's a modest sized city. There's a modest sized city here, but otherwise not much population on the west coast of Africa. But then down toward the south here, these islands, the Cape Verde Islands, these islands have the potential for seamount slides. And those seamount slides could cause a tsunami that could travel across the Atlantic Ocean and cause damage on the east coast of the United States. But it is what it is. So we don't have a tsunami warning system that's common on the east coast of the United States, but people who live on the west coast and people who live in Hawaii know about tsunami warning. There are oftentimes sirens that are put around town, and when they go off, you got to head uphill. And I visited places in Hawaii, and at school they do just like how we do fire drills, and places in the Midwest do tornado drills. They do tsunami drills, and how the tsunami drill goes is it's all for one and one for all. You're not waiting for a bus to come pick you up. You're not traveling as a class. The tsunami siren goes off, and your job is to go uphill as fast as you can on your feet, because like if we needed to evacuate this building and do it by bus, it might take an hour for the buses to get here. It actually takes a long time to arrange that. In fact, sometimes when we have an early dismissal, they might be like, hey, we're going to do an early dismissal, we're getting out in 30 minutes. The school's already decided that well in advance. They have to arrange to get the buses up here, but they just don't want you to be too excited for too long, I guess. You don't have that kind of time. If it were to be a landslide, a seamount slide in the Big Island of Hawaii, the time from Hawaii to Maui, from the Big Island of Hawaii to Maui, is literally just a couple minutes. You're like, this falls into the ocean, people here, they're going to get hit in like 4 minutes. So some of the tsunami warning systems are automated systems that are tied to seismometers or earthquake detectors. Earthquake goes off, you don't know if it's going to be a tsunami or not, but you don't wait to find out. You just sound the siren and get up the hill, and they know where to go and what to do. You just got to get up the hill. That's all you got to do. You just got to go up, right? Because if you're up, the wave can't get you. If you're hanging out in a coastal community like we saw with Japan, they're like that, and you're on that low area, those waves are unforgiving and fast, and you can get picked up and carried by the wave, and it can do absolutely tragic damage. So the evidence that he was talking about is here around these islands. So the western side of the island of Kauai is the oldest of the islands in Hawaii that's commonly populated, and it's this side here that's heavily eroded, partly by wave action. So waves actually play a role too. As waves and tides hit the side of the island, it erodes the island and makes the rock above it more susceptible to landslides. But you can see here on the ocean floor, out in here, there's very unique ocean floor surface detail. But then this bit here is really kind of smooth. This is as a result of a seamount slide or a landslide. So part of this island broke off, slid down into the ocean, and created this kind of flat area. It's the same thing up here. So you can see there's detailed features on the ocean floor all around up in here. But then this bit, this is not very detailed at all. This is an indication that there was a landslide, and you can even see where that land came from. So you can see here, this is a different color and a different shape for the island than over here or over here. And this shape is pretty much the same shape and size as this little bit here. So at some time in the past, this part of the island fell off, went down in the ocean. This is the strewn field of the rubble, and it would have created a tsunami that would have headed north. And in this northerly direction, that tsunami would have got up to like the Aleutian Islands in Alaska and did damage. But that wasn't like 5 years ago or 10 years ago or even 1,000 years ago. It could have been 100,000 years ago. It could have been 1,000,000 years ago, you know, just in the incredibly distant past, but still like happened nonetheless. So in oceanography, we see those indications of the seamount slide or seamount slides and landslides all around the islands. So these flat places up in here, this flat place here, these flat places are as a result of the landslide going down into the ocean, and then it kind of runs out and leaves like a flat area instead of it being in a way like the canyons get filled in. So you can see, like for example, here's a canyon here and a canyon here. Those canyons would have extended up to the island itself, but as a result of landslides, those canyons end up getting filled in. That's what we're pretty sure, you know, happened over time. And that's the way that goes. So whenever we did the thing about bathymetry and we saw that areas are flat, it could be as a result of sedimentation, like in a bay, from transported material that slows down and all settles into the holes in the ocean. But around volcanic islands, most of that flat part is as a result of landslides and sea slides. So over time, these islands are going to go away. They're going to disappear. This island up here will eventually erode completely into the ocean. It'll be uninhabitable. But at the same time, the southeastern part of the big island of Hawaii continues to grow, and new islands will form. There's these other little hotspot features, and there will be new islands in Hawaii that are down there. I'm not saying that like within your lifetime this island's going to go away, but some things do disappear. I can show you, for example,